and we'll move on to the last session before the coffee break. Dr. Glenn Suter from the US EPA.
Thank you all for coming, and I will do my best to not keep you from your coffee. Could I have my slides, please? I'll give you a little background. What I'm presenting is the preliminary results of an effort by the Ecological Oversight Committee of the EPA's Risk Assessment Forum to develop some guidance on how to do weight of evidence in the agency. This effort is underway. It has to go through a number of peer review and management review hoops, so it may come out the other end looking very different from what I'm going to be presenting to you today, so you should consider this just my opinion and not EPA guidance. Is that better? Okay, and I should also say that this is just for the eco side, not for the human health side. They feel they're not ready yet to develop guidance, and this, I believe, is typical of the ecologists being in front of the human health people. In developing risk assessment, we developed a lot of the fundamental concepts like problem formulation, and Harvey, the adverse outcomes pathway was adopted so easily by human health risk assessors because it was developed by ecologists. What do decision makers and stakeholders need? They need qualitative information. Does the chemical cause cancer? Is the ecosystem impaired? What is the cause of observed effects? And they need quantitative information. What concentration would be protective? How much salmon habitat would be lost to a mine development? How long would natural remediation of a contaminated site require? And they need to know the confidence in both types of information. And this is something that Andrew Sterling said yesterday, that we really don't need uncertainty. What we need is confidence. The decision maker needs to know how confident they can be in going forward with a decision based on the results of the risk assessment. So, what is confidence? I'm going to argue that confidence is a result of two fundamentally different kinds of information. One is about the scatter of data and results, conventionally divided into variability and uncertainty. And the other is the weight of the evidence, which is a result of three attributes: the relevance, the reliability, and the strength of the evidence. So what is scatter? It's anything that can be expressed as a numerical distribution. Variability is natural variation in some quantity. Uncertainty is incomplete or imprecise data or information which can be reduced by more study. And if you're a Bayesian or some other sort of subjectivist, you throw both of those out and you say it's just degree of belief. It subsumes both those concepts, and you can think of it as what sort of betting odds would you accept on a given scientific hypothesis. But this is all statistics. It's controversial but familiar, and I won't spend much time on it, but we'll come back to it later. What is weight of evidence? As Lawrence pointed out, it's a metaphor from jurisprudence based on the scales of justice. And we use it in three different ways. The first is it's the influence that evidence should have on an inference. It's the weight of a piece of evidence that's dropped into one of the pans of the scales of justice. It's also a summary interpretation of the multiple pieces of evidence. What is the weight of the body of evidence in one pan relative to the other? And finally, it's a term we use to describe an inferential approach that uses this concept. It's often simply based on an expert narrative, but we're trying to make it more formal, transparent, and defensible. This is our three-step weight of evidence process. This is about how to do weight of evidence. It doesn't include the first two phases that Lawrence presented this morning because we consider those to be part of the problem formulation that goes on before you begin doing anything in the risk assessment. So first you assemble evidence, then you evaluate and weight the evidence, and then you integrate and weigh the body of evidence. And we think those are the fundamental steps in the process. Of course, it's more complicated than that in practice. We elaborate each of these boxes. First step is to search the literature using a systematic review, which should be thorough and unbiased. Then, if you have the luxury of actually doing some research or observations to develop new information, you can do that to complement what's already known. Then you screen both of those sources of information and eliminate irrelevant and unacceptable studies. Then you categorize those studies, put them in bins that can be treated as a type of evidence that's similar and can be thought of like we think of, say, acute lethality, toxicity tests, reproductive tests, field biological surveys, mechanistic studies, etc. Then you don't just use the data, or in particular, you don't just use the results right out of the literature. We don't consider other people's analyses entirely reliable. We prefer to gather the data and reanalyze it. Also because the people who do research and testing often don't understand the needs of risk assessors and don't analyze the data in the way we'd like it to be analyzed. And finally, evidence often requires combining information from different studies, exposure response and the exposure information and something about the environment creates what we call an evidence cluster. The second step, weighting the evidence, we evaluate the evidence with respect to three attributes and assign scores. We weight the relevance, and I think everybody understands what we mean by relevance. We weight the reliability, and that's a whole lot of different things. We have 11 different sub-attributes for reliability. It's the conventional quality characteristics of the study design, and a lot of other things that we don't really have time to go into. And then there's strength, and this is one that's often left out, but clearly if you have a dose-response relationship that has a nice high slope, has a high R squared, et cetera, you would give that more weight as an indication of a causal relationship than one that had a rather flat sort of relationship. And you weight those using, in our case, a system of explicit weights based on plus, minus, and zero symbols. Plus for supports the hypothesis of interest, minus for tends to refute it, and zero for ambiguous. And finally, the last step is weighing the body of evidence. And first we begin by determining the overall weight of the body of evidence for each hypothesis based on the weights of the pieces and types of evidence and on the consistency across pieces and types of evidence. Then we interpret the findings based on the bodies of evidence, which, if any of the hypotheses are supported by the weight of evidence, and how much weight does the evidence provide for that conclusion that we have found the best supported hypothesis. And then the part that's often skipped particularly by people who haven't done weight of evidence is in fact, you often get to the end and you can't make a clear decision. As one of my gentle lady colleagues says, we get shit for data. So you have to have a way of dealing with that, and that can involve recommending gathering more data of a particular type. But often what you end up with at the end is a better understanding of the situation, and you find that you can actually gain a lot of ground by reformulating your hypotheses and approaching the problem in terms of a different set of alternative hypotheses than you began with, and you can repeat the analyses with that understanding. So how do we express those qualitative results? An example would be the chemical is a vertebrate teratogen. The relevance of the evidence is high. The strength of the evidence is moderate. The reliability of the evidence is moderate. And the consistency is high. That's the kind of summary results that we believe are useful to a decision maker. So how then do we link that kind of a qualitative weighing of evidence to obtain a qualitative result to quantitative results? The first box here at the top, weigh the evidence for the quality to be quantified, is the three boxes that I just walked you through. It's a teratogen. We've just established that, and now we want to determine a protective exposure level with respect to that teratogen. And here's where we get back to doing statistics. We gather the quantitative information that we have with respect to that quality that we've just determined. And we can take two different approaches, both of which involve weighing the quantitative evidence. We can choose the best quantitative evidence. We can weigh each of the alternative sources of evidence with respect to the quantitative exposure-response relationship for the terata, and we can say how much weight we should apply to each. And it may be, and it often is the case, that one of the sources of evidence is much stronger, much more reliable, much more relevant than the others, and we choose that one based on its high weight. But in other cases, we can find that there are multiple studies with roughly the same weight, and then we're back we're into the meta-analysis framework. We take each of the studies, we consider numerically weighting them and combining them in some manner. Typically, it's just a weighted mean of some sort. And then we go to the bottom and we define confidence in the quantitative evidence based on both the qualitative weighting we've done and the quantitative weighting that we've done. And I skipped my little arrows. So how do we express those quantitative results? We use a variation on Ravitz and Funtowitz's NUSAP system, which some of you may be familiar with. We break down the results. And first, what is the quality? It's that we're interested in. It's protection from deformities. What is the number? It's 22. The units are milligrams per liter. The scatter is expressed as a 95% confidence interval on that, which is 3. And the weight, this is the overall weight, taking in all of those qualities that we've discussed, is moderate. So each of these has supporting information. You wouldn't just present this little bit of information as your results, and more detail, but that's basically what comes out of this combined qualitative and quantitative weight of evidence system. Okay, and last slide. Summary: formal weighing of evidence can provide greater utility of results, increased defensibility of results, and increased transparency of the process. And we think that the last one is particularly important. The typical narrative weight of evidence that you see doesn't really show you what's going on in the assessor's mind, but this explicit process of breaking down the evidence and giving it explicit weights does. With flexibility and adaptations purpose, weight of evidence need not be onerous, and that's very much a concern of people in the agency, that we're putting a burden on people who are already overburdened. And in combination with conventional statistics, weight of evidence can convey confidence in the results. Thank you.
Really, really excellent presentation. And thank you for keeping spot on to time. That was absolutely perfect to the minute.